Hey guys, Miss Hybert here. Ready for a quick math lesson? Great. So today we are going to conquer something called cryptarithims. So cryptarithims are derived from a Greek word, cryptus, meaning hidden. So you are going to find the hidden numbers here and solve this puzzle today. So you're given some letters, which we're going to call variables, and we have to think about how those variables would work and what letters they represent. So it's going to be challenging today, but I've got a few tips to help you out, and we're going to solve these together, okay? So let's take a look at some of the things I've already written down to help us get started. So if you notice, you have letters here, and then you have these blanks that match up the same spaces for the letters. So basically, we have to find the numbers that these letters are representing. So each letter stands for a digit. A digit is a number. The same letter is equal to the same digit or the same number. So if you have a B and a B here, the number is going to be the same. Okay, so all the B's are the same number, all the A's are the same number, all the L's are the same number. There is only one solution, okay? And there can't be a zero in the greatest place value of any number. So you couldn't have a zero here, no zeros here. Okay, the greatest place value of the number can't have a zero. And again, there's only one solution, so you can't, everybody will have to have the same answer is what that means. A good way to maybe start some of these is to look for places that nines or zeros could go. You don't have to solve this in any order, okay? So solve the easy parts first. And then also think about numbers trading and carrying, okay? So those are going to make a little bit more sense once we get started. I've also written down numbers 0 through 9 to help us keep track of the numbers that we've already used and to kind of give us a visual of numbers that we can use because we can only use digits 0 through 9, of course. And we're going to mark them off as we figure them out for just one problem, okay? So each time we'll erase the numbers that we've marked off when we move to a new problem. So if you want to get an ink pen and write 0 through 9 somewhere on your paper or on a scratch sheet of paper, that way you can mark things off with a pencil and erase over top of your ink pen, and it won't erase your numbers underneath. But anyway, let's go ahead and get started with number 1. Number 1 says B plus A equals ALL. So we've got to think about what we know and really think deeply about numbers, place value, and number sense. So before you start a problem, you might want to look at the variables or the letters that are in there and make yourself a little chart like this. So we've got letter B, we've got letter A, and we've got letter L. That will just kind of help you keep track. Now, a lot of this is going to be guessing and checking. We might not guess right the first time, but we can guess and check and erase and go back, and that's just how you have to solve these problems, these puzzles, okay? So let's get to really thinking about our numbers here. And like I said, you can start anywhere in the problem. It doesn't have to be in any specific order. Now, what I notice, it's a 2-digit by 1-digit, but you end up with a 3-digit number. So obviously there's some carrying going on because you're ending up with like an extra digit right here. So we could think about what plus what is going to give me something that carries. Well, I know the greatest number I can work with is 9, okay? So is there anything plus 9 on my list here that will give me a 2-digit number? Oh, you're thinking, okay, 9 plus 1 would carry and make it 10. So I'm just kind of going to draw that in for now. So a 9 and a 1. 9 plus 1 would be 10, carry your 1, right? Okay, well, if this B is 9, like we think it might be, right? And the A is 1, like we think it might be, it must mean that L is 0. Okay, so then we've got just a few other letters. If we think A is 1, is there another A on our list here? Yeah, there's another A that goes there. And what were the B's? We were thinking B equals 9, and we think L equals 0. Oh my goodness, does this work out? 99 plus 1 equals 100. This works out just simply by thinking of numbers that would work in those spaces. We figured it out. Now, if it helps you, you can cross these numbers off, but since we're only working with a few variables there, we didn't really need to do that. But now that we finished number 1 and it works out, we can move on to number 2. Okay, so stick with me because it's not always going to be as easy as the first problem we just did. So let's look at number 2. The variables are who equals hoot. WHO plus WHO equals HOOT. Now remember, the variables, same letter equals same digit, right? So this looks like the same two numbers. So we've got to think of two numbers that are the same. So once we figure out the first who, we're going to know the second who, okay? So let's think about this. We're going to have a number that, look, that carries because we've got a 1 digit plus a 1 digit, and then we've got like an extra place value here. So we're thinking of a number in the ones, tens, hundreds, thousandths place. So we've got two numbers in the hundreds place that are going to equal a number in the thousands place, okay? Now, I would like to think it would be something as easy as like 500 plus 500. Whoops, I'm going to pick a color that shows up better. I would like to think it would be something as easy as 500 plus 500. But why equals like 1,000? But why would that not work? Look at our variables here. That would mean these two numbers were the same. It's just the letters don't match up. That's not going to work. Okay, so we have to think about what those variables are going to stand for. So what two numbers can you add together? Two of the same numbers that add together that equal something. Well, I know 1 plus 1 equals 2. But let's think about that. Would a 1 and a 1 work here as well? Is there something plus something that's going to give you 1? No, so we can't, we can't use 1. And, you know, as the variable for O, that's just not going to work for O. So let's think about 2. Would 2 plus 2 equal something? Yeah, for sure. So could you get something plus something that equals, you know, two numbers that equal 2 here and maybe two numbers that equal 2 here? Two different numbers? Maybe, especially if we need something to carry. So let's just, because we're guessing and checking, let's just try it out. If it doesn't work, that's okay. So in these boxes, we're thinking so far that O might be 2. Okay, now I'm only writing these the same because they're the same variable. Before I get too far, let me write my letters here. So we've got W, we've got H, we've got O, and we've got T. So we're thinking for now that O equals 2. Okay, well, if O equals 2, let's go ahead and put a 2 here and a 2 here where the other two O's are in our puzzle. Okay? All right, let's look at H. We've got a lot of H's here. So what two numbers can you add, together that equal 2? 1 plus 1. Let's give it a try. I don't know if it's going to work yet, but it might. So 1 plus 1 equals 2. So we're thinking that H might be 2. Okay, so we can write that down. Now, let's look at, how about we look at what we think T might be. We already have our 2 plus 2. So what do we think the only T in this puzzle might be here? 2 plus 2 is what, guys? 4. Good. Okay, so T might be 4. All right, so far we've used 1, 2, and 4. So it could only be a couple other numbers here. All right, now we know, here, I'm going to get my laser. We know that something plus something, it's not just going to equal 2. It's going to need to be a number either, I'm going to ask you this question. Are the two numbers, which have to be the same number, are they going to be greater? Is their sum going to be greater or less than 10? You're right. It has to be greater than 10. And greater than 10, you might ask, why? Because look, it's a 2-digit number right here that we have to get. So these two numbers together, added together, have to be greater than 10. So what two numbers together equal 10? 5 plus 5 equals 10. Could it be 5 plus 5 here? No, because that would be a 0 and a 1 that we would need to be looking for. That's not what we need. Let's go to the next number. Can't be 5. So let's just mark off 5. It can't be 5. We know that. Can it be 3 plus 3? No. Can it be 0 plus 0? No. Let's go to the next number. 6 plus 6. What does 6 plus 6 equal? 12? Oh my goodness. Yes, 6 plus 6 equals 12. Write down your 2 and your 1. Oh my goodness. We did it. We figured it out. 612 plus 612 equals 1,224. Now let's double check ourselves and make sure we've got this. 2 plus 2 is 4. 1 plus 1 is 2. 6 plus 6 is 12. We got it. We solved the second cryptogram. Okay, now it looks hard, doesn't it? But once you just think about numbers, it's pretty simple. So really there's, a few strategies you can use to solve this, but really a lot of this is just thinking hard about numbers. Wow, we're ready to move to the third one already. Now, if you notice, the third one is a subtraction problem. These were addition problems. So if we're working with subtraction problems, we're going to have to think about these differently. So let's think about what we know. We can go ahead and write down our letters that we have, our variables. We've got a W, we've got an M, and we've got an E. Okay, now since this is a subtraction problem, look at this. All these E's, they're all the same number, right? So what minus what would give you the same thing? Think about that. Something subtracting something has to equal itself. Guys, there's only one number that can do that. Think really hard and shout it at your computer when you figured it out. What number minus itself gives you itself? If you said 0, you're right. That's the only one it can be. 0 minus 0 equals 0. So I'm pretty sure that E is going to equal 0. That one I'm pretty sure about. Now, if you look in our puzzle, we have another E right here. So we're going to go ahead and pretty confidently say this part of our puzzle must be 0 too. So on our number line here, I'm going to go ahead and mark off 0. We've used 0 as a variable. I feel really confident about that. Now, the rest is what's going to be a little tricky. So 0 minus something, okay, is going to give you the same number. Now, we know, because we're good subtractors, we know you can't take 0 from something, so we're going to have to be doing some borrowing here, some trading. We're going to have to mark out the 0, make it a, what? We know we're going to have to make it a 10, you're right. So I'm going to go ahead and do that, and that might help us see this problem better. All right, so what minus 10? Think about this. Look at our problem. We've got, it's got to be the same number and the same number. So what minus 10 will give you the same number? Think about that. Did you say 5? I think I could hear you through the computer. Yeah, 10 minus 5 will give you 5. I'm pretty confident then to say that M is going to be 5. Wouldn't that work? It sure does. So I'm going to be pretty confident thinking that M must be 5, okay? So I'm going to go ahead and mark that off my little number line. I've used 0 and I've used 5. Okay, now look at this. Let's look at the puzzle as a whole. Sometimes it can be a easy habit to just be looking at each individual box, right? Back up a minute, zoom out, and look at this as a whole. What minus 50 is going to give you 50 with two, something minus 50. It's got to end in 2 zeros equals 50. Did I hear somebody yell 100? I think you're right, because look at that. Could W work as the variable for 100 or for 1? I think that would work. Let's take a look at our puzzle. Does 100 minus 50 give you 50? Yes, so let's do that problem fully and make sure we're right. 0 minus 0 is 0. Can't do 0 minus 5, so you marked out the 0, made it a 10, mark out the 1. We'd have to make it a 0, right? So 10 minus 5 is 5, and 0 minus 0 is 0. That works out, doesn't it? Okay, this isn't as hard as it looks. I know there were a few of you that looked at this page and said, oh no, I will never solve this. But look at you now, guys. We're already ready for number 4. So I think you're on a roll here. All right, we're ready to move on to the next one because we've checked ourselves and that works. So I'm going to erase my number line up here. And I'm going to take a look and think very carefully about number 4. So we've got the ET equals at. So we've got TAG minus ET equals AT. Oh man, okay, so let's take a look. I kind of like to start here, but it doesn't matter. You just solve whatever is going to be the easiest to figure out first. So what minus this T will give you the same number? So you're going to think about a number that's a half of something, right? Now there's a lot of numbers that are halves of things, aren't there? So before we get too far, let's go ahead and write our variables down so we can just keep track. We're going to have the variable T, the variable H, the variable E, and the variable A. Okay. All right, these are our variables that we have to work with. So again, what we're going to be, remember it's minusing, so there's going to be a number minus this number that'll give us the same number. So that's telling me that this that's telling me that this number down here, same as this one here, is going to be half of this number down here. So are there numbers on our number line that we can use that have halves? Does 0 have a half? No. Does 1 have a half? No. Does 2 have a half? Yeah. 1 plus 1 is 2. Okay. Does 3 have a half? No. Here, I'm going to underline that too because that's a number we could look at. That has a half. Does 3 have a half? No. Does 4 have a half? Yes, it does. 2 plus 2 is 4, so 4 has a half. All right, does 5 have a half? Nope. Does 6 have a half? Yes, it does. 3 plus 3 equals 6. So I'm going to underline 6. 6 could have a half. That could be a potential number here. All right, and let's look at 7. Does 7 have a half? Nope. Does 8 have a half? Yes, it does. 4 plus 4 is 8. So that number could have a half. And does 9 have a half? Nope, it sure doesn't. So, like I said, this is just kind of like guess and check. We're just thinking about these numbers, seeing what works. So let's start at the beginning of our little number line here. We've kind of eliminated some by, thinking, okay, it's got to be a number that has a half. So our first number that has a half that comes up on our list is 2. All right, so if this were 2, remember the 1 is half of 2. So would this work? 2 minus 1 equals 1. That might work. Now, would 4 minus 2 equal 2? Yeah, any of these numbers would actually work. So let's think about which number would work the best. Okay, so if this E, if we're thinking this E might be a 2, because we're just guessing for right now. E might be 2. And we're thinking T might be 1. Let's just fill that in. Remember, we can always go back and erase. So we're thinking E might be 2. So let's fill in all the E's. There would be a 2 here. And then let's fill in the T's. There would be a 1 here. And there would be a 1 here and a 1 here. Okay. Again, we're just guessing and checking. So for now, I'm going to mark off the 1 and the 2 because we've used both of those. Let's just see what happens, okay? All right. So far, that works. Works right here. And, of course, it might work here, too. All right, let's look at H now. So I've gotten this row. Let's see if I can figure out what this row might be. Blank minus 2 equals blank. All right, I also want you to zoom out. Take a look at the whole puzzle. Looks like we''t got 100 something 2. So something in the 102 or something like that minus 21. We know this number's 21 equals blank, a 2-digit number. So we need to think about how we can figure out the rest of these blanks. And we have these numbers left to work with. So we can just start plugging stuff in and see if it works. Honestly, that's the best solution for this. That's why I really recommend writing down 0 through 9. That way you can really see what numbers you have to work with and just start plugging them in. Because really that's what this is all about, is plugging stuff in, see if it works. If it doesn't, go back and erase. So let's take a look. What's the first number we have to plug in? I mean, that's really my strategy at this point is, can we plug something in here? Well, I see there's a 0 to plug in. All right, now that would fill up, that would give us at least 2 numbers to work with here and see if we can actually solve the problem, okay, and see if this actually works. So we're thinking that H, just because I'm plugging stuff in, might be a 0, okay? So that would leave us only looking for variable A, and we could figure out variable A just by actually doing the math problem. So let's actually do the math problem and see if it works out. So 2 minus 1 is 1. Yep. 0 minus 2. Can you do that? No, you can't. So you mark out the 0. make it a 10, mark out the 1, make it a 0. 10 minus 2 is what, guys? 8, and 0 minus 0 is 0. So wait a minute. Would this actually work out? Would 102 minus 21 equal 81? Yeah, it works out. So, okay, what is the variable for A then that we've discovered? Yeah, A would be 8. That works. That's it. Wow, how about that? So again, having these numbers up here, I think have helped me out the most just by staying in order and just plugging stuff in. That's it. That's the answer for 4. 102 minus 21 equals 81. And we just figure that out by thinking about numbers and plugging them in. Thinking about what numbers would work and could work, and then plugging them into those spaces. Good job on number 4. Let's take it up a notch and solve number 5 together. So I'm going to grab my eraser, erase my little number line up here so I can use it for the next problem. All right, so the next problem says bow plus wow equals woof. All right, so let's look at our variables and go ahead and list them below. So we've got a B, we've got an O, we've got a W, and we've got an F. So those are the variables that we are going to work with here. All right, let's take a look at what this is showing. 2 numbers that are the same number, right? Because it's the same variable. So these 2 numbers have got to equal something. So, you know, 0, this could be 0 plus 0 equals, could it be 0? No. Because 0 plus 0 is going to equal 0. So we know W is not going to be 0. So let's look at 1, maybe. Could 1 plus 1 be something different? Yeah, 2. So just because that's how this problem kind of works, let's just plug it in. So 1 plus 1 would equal 2, and that would kind of match our variables here. So we're thinking that maybe W could be 1, so that would mean F might be 2. So let's just plug it in and see if it works. 1 plus 1 equals 2. Now, if you notice this here, look, this is going to have to be a sum that equals greater or less than 10. Yes, it's got to be greater than 10 because, look, it's got an extra place value. So do you see any other variables here that we can add? Is there another W that we can add? Yeah, we're thinking this has got to be a 1, and maybe this one would be a 1. All right. So that kind of helps us a little bit. If we're thinking 1 plus 1 is 2, and then this has got to be something, the sum of these 2 numbers have to be greater than 10, right? So what number do we start with to get a sum greater than 10? What could we add to 1? Because we're thinking W's are 1s. What could we add to 1 to get 10 or greater? 9. Yeah, we could add 9 plus 1 and get 10. So maybe now we're thinking that B might be 9, because we know 9 plus 1 would equal 10, and that would work out. So the O's, wait a minute now, the O's must be 0. That's kind of handy. So we're thinking the O's might be 0. Are there any other O's that we could fill in? Yeah, there's an O here. There's an O here. And wait a minute, that leaves us with the last O. Oh my goodness. Does this work? Let's look and see if this works, because we've got all the boxes filled in. Let's see if this actually works. Okay, 1 plus 1, 2. Yes, that works. Yay. Okay, 0 plus 0 plus 0. Yes, that works. Equals 0. 9 plus 1 equals 10. Yes! Oh, I just get so excited when these work out. This one worked out. See, you just got to think. You just got to think, and you can get this. All right, that means we're ready for number 6. Now, number 6 is going to be pretty challenging, but I know we can conquer it. Look at all the ones we've conquered so far. We can do this. So, if we look at number 6, it is a subtraction problem, and it reminds me a lot of number 3. We minus me equals me. Okay, so one number minus a number equals the same number as before. So one number minus a number equals the same number as before. So look at how we got the answer, or look at the answer we ended up getting. Like it was half. 50 is a half of 100. So 100 minus 50 gives you 50. 50 plus 50 gives you 100. So we know we're going to be finding like half of whatever this number is. So before we get into everything, let's go ahead and list our variables. And that way we can kind of keep track. So we've got C as a variable, O as a variable, W is a variable, S is a variable, and M is a variable. So lots of variables here. We've got 1, 2, 3, 4, 5 variables to find. All right. Another thing that I've noticed just by practice with this one, which is very similar to this one that we've discovered, is, and it's also similar to this one. You've got a number in the thousands place minus a number in the hundreds place equals a number in the hundreds place. So I know this number now. So because this is a subtraction problem, what does this number have to be? What number minus 0 will give you 0? But remember, 0 can't be used as the greatest place value. We know that there's going to have to be some borrowing going on like there was in the other problems that are similar to this one. So what do you think would be the best guess for this digit right here? I'm thinking, and I hope you are on the same path as me, that C, the variable C, would be 1. Why could C be 1? Well, because all these digits we're probably going to be borrowing. So at some point, this 1 is probably going to get marked out and made into a 0. That's my guess, but I think it's a pretty good guess to start with, okay? Let's think about some other things that we could plug in for these boxes here. So we know it's going to be a lot like number 3 because these two numbers are going to need to be the same. So a strategy we used that worked really well in number 3 was underlining the numbers up here that were halves. So 2 can be halved, 4 can be halved, 6 can be halved, and 8 can be halved. So that might be a good place for us to start, is by plugging in some of those numbers that can be halved. We'll see if that works. So let's try 2. Would it work for variable S to be 2? Ooh, why not? I'm glad I'm hearing a lot of no's from the computer magic. It couldn't be 2 because that would mean 1 would have to go here, and 1 has already been used. So 2 cannot be one of our guesses so far. So I'm going to go ahead and mark off 1. I'm going to mark off because we've already used it for C, and I don't think 2 is going to work in our case there, so we can mark off 2. Let's look at 4. Could 4 work? If we put 4 here, we would need to minus 2 to get 2. So far, maybe 4 could work for here. So we're thinking that the S variable might be 4. And then we're thinking that the O variable might be 2. So all these O's would be 2. Let's see. So 4 minus 2 is going to be 2. Now, would that work for here? Something minus 2 is going to be 2? Wait a minute, that's not going to work. The only thing minus 2 that would give you 2 would be if this was a 4. And we know that that can't happen because S is already 4. So let's go ahead and we're going to need to erase. So I'm going to grab my eraser and get rid of all the 2's here. So O can't be 2. I'm going to have to think of a different strategy now. If I'm pretty confident that S might be 4, is there anything that I could subtract that might work for there to be the same 2 numbers here? So a number that's the same here and a number that's the same here. Maybe we shouldn't think about this 4 as a 4, because I'm definitely thinking there's probably going to be a lot of, borrowing in this problem. So what if we thought of this 4 as a 14, like there's a number that's greater than the 4 underneath it. So you couldn't do 4 minus something. So you would have to mark out the 4 and make it a 14, right? So is there something minus 14 that gives you the same number? Like, what's half of 14? 7. 7 plus 7 equal 14. So 14 minus 7 would give you 7, and that's like what we're looking for here. So our next guess is that maybe the O's could be 7's. Let's plug it in and see if it works, okay? So there's an O there, an O there, an O here, an O here, and an O here. So that's just our guess. We're trying to think about this differently because what we were doing before didn't work. So let's say that O might be 7 instead of 2. Okay, is there something different minus 7 that would give us 7? Well, it's only 14, right? Well, here we marked out the 4, made it a 14. So that would mean this number has to be something that gets marked out. So, if we put, is there any way that this would ever turn into a 14 to make this 7 and 7 work? Well, if this number were a 5, it would get marked out and made into a 4. If we borrowed, let's say this is our number and we're borrowing, we would mark out the 14, mark out the 4, make it a 14, mark out the 5, make it a 4. Well, when we move to the next place value and subtract, we're going to realize that isn't going to work. So we mark out this 4 and make it a 14. I think I just found a new variable. W must be 5. So I'm going to write that down because I think W might be a 5. Okay, so I can mark off that. I've used 5, and I can mark off 7. I've used 7. Okay. Let's keep going. Let's see if this works. Let's see if this guess and check is working. So if we mark off this 4 and make it a 14, that means we have to borrow again. Mark out this 7, make it a 6. Okay, 6 minus what would give you the same thing? 3. 6 minus 3 would give you 3. Let's see if that works. So 6 minus 3 would give you 3. And then what? Wait a minute. I don't think we're right. M can't be 3. Because look, 6 minus 3 equals 3. Then 1 minus nothing would equal 1. And we don't have a box for that. So, back to the drawing board again. M can't be 3. Let's go ahead and mark off 3. Can't use that. Could we use, so let's just look at our number line up here and Use a number we haven't used yet. Could we use 0? 6 minus 0 equals 0? No, that wouldn't work there. Mark it off. Could we use 4? 6 minus 4 equals 4? Nope, we can't use that one. Mark it off. Let's look at 6. 6 minus 6 equals 6? Nope, can't use that. Let's look at 8. 6 minus 8 equals 8. Well, could you do 6 minus 8? No, you couldn't. So you would mark out the 6, make it a 16. Mark out the 1, make it a 0. Wait a minute. 16 minus 8 does equal 8. And 0 minus 0 equals 0. So our variable m must equal 8. And because we have our nice little number line that kind of helps us go through all the different numbers, we know that this would work. So with all that chicken scratch, I hope you can read it. I'll write it better. 1,754 minus 877 equals 877. So you did it, guys. That is the last cryptogram we had to figure out today. So wow, that was super challenging, but I'm glad I could work with you guys together on each one of these. And I hope your brain has grown 10 sizes. I know mine has, just trying to figure this out and think through these numbers. So that's how you solve a cryptogram. A lot of guessing and checking, a lot of plugging things in, and being careful and methodical when you are trying to solve these problems, okay? So I hope you had fun working with me on those, and it was nice to have math class with you over YouTube. So until I see you again, 4th grade, have a great time figuring out the rest of your math boxes. That's all you have left to do after this, and I will see you guys next time. Bye.